We're going to move on with this chapter, this algebra chapter, with linear equations and two variables. You're going to learn how to graph equations in this section. First though, before we learn how to graph, you're going to learn how to check your answers. So know that in this section you're going to see equations that look like this. 2x minus y equals 5. Do you see why it's called linear equations with two variables? Those two variables are usually going to be x and y because they relate to the x coordinate and the y coordinate, or the x-axis and the y-axis. So know that the answer to this equation will always be an ordered pair, and there's going to be more than one because it's about the relation. So you're looking for ordered pairs that make this solution true. Well, on your homework, they're going to ask you to check solutions. So they're going to give you an equation. I'm going to give you a new equation so you see a bunch and you know what they look like. They're going to give you equations such as x minus 3y equals a negative 1. They're also going to give you ordered pairs. So maybe they're going to give you 4, 2, and maybe they're going to give you 2, 1. Your job is to see if either one of these is an answer or solution to this equation. To do that, you're going to plug it into the equation. And you see that this is an ordered pair. This is your x and this is your y. So I'm going to plug in 4 for x and 2 for y and solve to see if both sides of the equation are true. So I'm going to substitute this in here. My x value is 4. My y value is 2. Okay. Order of operations, I'm solving on the left side of the equal sign. 3 times 2 is 6. 4 minus 6 is a negative 2. Now, are both sides of the equation equal? Absolutely not. This is not true. This is not a solution to this equation. So let's try the other one. This is my x, this is my y. So 2 minus 3y equals a negative 1. 3 times 1 is 3. 2 minus 3 is a negative 1. Do you see how both sides of the equal sign are the same? These are the same. So that means that this is a solution to that equation. This is an answer to this equation. There are more. We only found one. Okay. The next part of this section is called finding solutions. You do not have to write this huge paragraph down. Just make sure you're following along here. The number of pages P, now P stands for pages, that Donald has left to write for his 30-page research paper depends on how many days, D stands for days, he writes 5 pages per day. This situation can be modeled by the equation, look, they give us an equation, P equals 30 minus 5D. Now remember, P stands for pages and D stands for days. Make a table of solutions for the equation. So when we're making a table of solutions, you're going to use a T-chart. It can be vertical or it could also be horizontal, it doesn't matter. So here, our T-chart, I'm going to use, instead of x and y, I'm going to use D and P. D stands for the number of days and P stands for the number of pages that he writes. Now, P depends on D, so that's why D comes first. It doesn't tell us how many days, so you're going to have to come up with x values or inputs or D values. So maybe I'm going to think easy here. I'm not going to be in the hundreds or anything. I'm going to do 0, 1, and 2. Okay? I want to see how many pages he has written after 0 days, how many pages he has written after 1 day, how many pages he has written after 2 days. Maybe you can even see this without even doing the equation. I would like to see the work done for this. Don't do it in your head. So to find P, I'm going to input 0 for D. after 0 days, how many pages does he have written? This should be obvious. 5 times 0 is 0, 30 minus 0. He has not written any pages. He has 30 pages left. Okay, how many pages does he have written after 1 day? So 5 times 1 is 5. 30 minus 5 is 25. He has 25 pages left to write after the first day. How many pages do you have to write after 2 days? Well, 5 times 2 is 10. 30 minus 10 is 20. Okay, so we just did what they asked for. It says make a table of solutions for the equation. Here's a table of solutions. You don't have to do any more than 3, but I would like to see at least 3. Let's take a look at what the next situation says. How many days does he need to finish his paper? So we want to know how many days does it take to get the paper to be 0. Well, we're going to take this equation and we're going to have to really think about what these variables stand for. P stands for pages and D equals days. How many days does he need to finish his paper? Well, we're trying to figure out D, so that's going to stay a variable. We want to know what's D when P equals 0, when he has 0 pages left. So I'm going to substitute in 0 for P. And I need to solve for D. So I'm going to, don't touch this first, you always start with the term that does not have the variable. Negative 5D, I want to get D by itself, so I'm going to divide by negative 5. So I get D equals negative 30 divided by negative 5 is 6. It looks like it would take him 6 days to finish, make sure you label, finish that paper. Alright, here comes the fun stuff. We're going to learn how to graph a linear equation. I do want to point out something to you. When they're talking about linear equations, linear means a straight line. Okay, so all of your equations should be a straight line on this assignment. So note that a graph, when you graph, it represents a set of all points in a coordinate plane that represent all solutions of an equation. So like I said before in the last slide, an equation, its solution is an ordered pair, but there are multiple ordered pairs. When you graph a line is not just one ordered pair, it's a set of ordered pairs. So you're looking for those solutions on that straight line. It might not be vertical or horizontal, it might be diagonal, that's okay. Okay, so let's start with y equals 1/2 x minus 1. I'm going to write a set of steps over here so we can follow along, so you can do this in the future. Your first step is to create a table. So I'm going to set up a T-chart here, and I'm going to have inputs and outputs, and I'm going to have x's and y's. You have to pick the x values. You have to pick the inputs. I want you to pick at least 3. More is better, but the smallest amount you can have is 3. When you're picking x values, choose easy numbers. If you pick a number like 20, when you make a graph, when you actually graph it, your graph is going to be huge. So I'm going to pick small numbers like -1, 0, and 1. You could even do 0, 1, 2, whatever you want. After you create a table, your next job is to find your y values or the outputs. So you're going to solve for your y values. Okay, so we've done this in the past. To do this, all you're going to do is plug your x values. I have 3 different problems. Your x values into the equation. So I'm still going to start with -1. -1 times 1/2 is -1/2. Okay, here I have the same sign, so I'm adding. -1/2 plus a -1. Well, 1 plus 1/2 is 1 1/2. Because they're both negative, I'm going to have a -1 1/2. Okay, now I'm going to plug in 0. This should be the easy one. 1/2 times 0 is 0. 0 minus 1 is a negative 1. Last one right here. Plugging in 1. 1/2 times 1 is 1/2. Okay, now this is a subtraction problem. I'm going to reverse these in my head so it's easier. 1 minus 1/2. 1 minus 1/2 is 1/2. Because this is a bigger term, that half is negative. Now, if you can't do it in your head, it's okay to make this into a fraction and find a common denominator. There is nothing wrong with that. After you have your input-output table, your T table completed, you're going to graph. Now, these are ordered pairs. You're going to think of them. You don't have to rewrite them, but I'm going to do this for this problem. You're going to think of this as negative 1, negative 1 and 1/2. 0, negative 1, 1, negative 1/2. Okay, and I'm going to graph those three ordered pairs. Okay, so I'm going to highly suggest that you use graph paper for this, because later on in this chapter it's going to get more complicated. So it's going to be easier if you start using graph paper right away so you get used to it. And straight edges, rulers. If you don't have graph paper at home, you don't have to go out and get any. Just print it off online. Google graph paper. Okay. Negative 1, negative 1/2. Negative 1, negative 1 and 1/2. 0, negative 1. 1, negative 1/2. Okay, so I have a straight line going here. This is where you're going to want to use a straight edge to connect your dots. So your answer, the graph is just a tool to help you find ordered pairs or the answers to your equation. Your answers to this equation are any ordered pairs that lie in this line. Okay, I do want you to try one of these. Try y equals a negative x plus 3. So push pause and give it your best shot. I'm going to start by making a t-chart. You may have chose different values than me. I'm going to use negative 1, 0, and 1. Even if you chose different values, your line should still be in the same direction as mine. Okay, now I have to substitute these into the equation. Y equals a negative. My x value is negative 1 plus 3. A negative times a negative is a positive. So my first output is 4. I'm going to plug in 0. Negative 0 plus 3. Well, there is no such thing as a negative 0, so I'm left with just 3. Y equals a negative. My x value is 1. Negative 1 plus 3 is 2. Now I get to graph. Ordered pairs are negative 1, 4, 0, 3, and 1, 2. Now, if my graph was drawn evenly, this line would look better. Okay. It's kind of hard, because I'm not using graph paper, it's kind of hard to tell what the other ordered pairs would be. That's why it's important to use graph paper. But this is what your line should look like. So we've just talked about how to graph equations that are diagonal linear equations, but you're also going to have vertical and horizontal lines as well. So this section is graphing horizontal and vertical lines. Okay, so I'm going to kind of show you what they're going to look like here. A vertical line will always be x equals a number. A stands for any integer. It can be positive or negative. This is a vertical line. Okay, so if you were to graph this, you're thinking of an ordered pair, whatever this integer is, and 0, because your x value is this number. For example, let's say you have x equals 1. You want to graph this equation. There's no y, so it's not going to be a diagonal line. So if I were to graph this, you're thinking of the ordered pair. Now this is your x value, 1, 1, 0. Okay, here's 1, 0. There is a line, a straight line that goes through this dot. And that line, that's not very good, that's why I use a straight edge, is a vertical line. Okay, there it is. Whenever you have x equals a number, it's always a vertical line. If it's x equals -4, you would have a straight line going through -4 over here. If it's x equals 0, you would have a straight line going through 0. Okay, so let's say you have a horizontal line. Instead of x equals a number, you're going to have y equals a number. I'm going to use b. It can be any integer. So when you're graphing, you're thinking, because this is y, 0, and then whatever that number is. So for example, let's say you have y equals -4. You are thinking, when you graph 0, -4. I'm going to go to 0, -4, and there's a straight line that goes through there because there's no x here. There's only one variable. So I have a straight horizontal line that goes through x, -4. So if you have, not x, y equals -4. If you have y equals 3, you're going to have a straight line that goes through here. If you have y equals 0, you have a straight line that goes through here. It's important to remember, because kids get this confused, whenever you have x equals a number, that line goes through the x-axis. Whenever you have y equals a number, that line goes through the y-axis. It's not, see how this is the y-axis? Do you see how it's not going in the same direction as the y-axis? It goes through the y-axis. Okay, they're going to take this one more step further. So we have one type of problem. I know this is getting long. Stick with me. This is write an equation in function form. Okay, so not all your equations are going to be in function form. So let me show you what I mean by that. You might have an equation that looks like this. 3x plus y equals 7. This is not in function form. We can graph this equation by getting it in function form. So meaning you need to solve for y. Okay, you want to get y by itself. Function form is when y is by itself. So I'm going to take this equation and solve for y. I want this by itself. Well, to get this by itself on the left side of the equal sign, I move this whole term to the other side. It's positive here, so you're going to do the opposite and subtract. So over here I'd be left with y equals 7 minus 3x. I can't combine those terms. They're not like terms. You can leave it 7 minus 3x. Or you could switch those terms around and you could think of it as negative 3x plus 7. Either means the same thing. So this is in function form when y is by itself. And from here, you can go ahead and graph it. I'm not going to graph it because this is just like the 3 steps that I showed you earlier in this video. Alright, I want to show you one more of these. Actually, I want you to try this one on your own first. So if they give you an equation, they ask you to graph this function or graph this equation, and it's not in function form, or the y is not by itself, you have to do this first before you make a t-table. You have to get y by itself. So go ahead and try this on your own first. Push pause. Okay, so I want to get y by itself. I'm going to start with a term that does not have y. Okay, negative 3y is left over here. I could do 3 minus 2x or negative 2x plus 3. Means the same thing. Y is not by itself yet, so they're multiplying. I'm going to do the opposite and divide. And I don't know if you've seen this before. I'm dividing this whole side by a negative 3. So this is just like saying 3 divided by a negative 3 and negative 2x divided by a negative 3. You have to divide both of these terms by a negative 3. Okay, so when I do this, 3 divided by a negative 3 is a negative 1. 2 divided by 3, we can't do that, so we're going to leave that a fraction. A negative divided by a negative is a positive. So when it doesn't come out nicely, you leave it a fraction. The x can stay in the numerator or it can be pulled out. It means the same thing if you leave it like this or if you pull it up like that. Okay? Alright, make sure you read the directions and make sure to use graph paper on this assignment.